When we talk about inclined planes, the main focus will be on the keywords that says up an incline and down an incline, whether it's pushed or pulled. Then for most of other things, it is still the same approach throughout. For example, for mg, now our weight, we have to resolve it into components. Why are we resolving the weight into components? As you notice, the weight at this point is not parallel or perpendicular to our plane because we've moved to an inclined plane. So now our weight ends up forming an angle away from the perpendicular component of that plane. So now we have to resolve it into components. We'll have a perpendicular component to the plane and the parallel component to the plane. The perpendicular component to the plane is the FC, whereas the parallel is the FS. As usual, your FT should go with the keyword which is up an incline, and also F mu must oppose the movement of the block. I'm sure you have noticed that our FT is parallel to the plane. That is why we do not need to resolve any component. In fact, there are no vertical components, so we can't. Instead, we'll find out how to make FT the subject of the formula using our equations, as you can see. Have you noticed that you do not need to go through the F mu formula in order for you to get the FT for this equation? But at the same time, if you decide to follow that long process, there is an answer, or there is a way of doing it, which is this one right here. And similarly, when the keyword is down the slope, we still follow the same steps, same concept. F mu opposing FT, FT parallel to the plane, and FT going down the slope as the keyword shows us. For this section of the inclined plane, you should also notice that the perpendicular forces are always the same, whether it's up or down the slope, as you can see. Then from this you can make FT the subject of the formula, or you can again follow the formula from you to make FT the subject of the formula. Whichever way, we win.